Hi, hope you're enjoying your vacation. This is the review for your midterm examination, and I'm going to do a series of videos that will review each topic. The first topic is Chapter 4, Atomic Structure. And then the next one will be Electrons, it's Chapter 5, and then Chapter 6, etc. Okay? All the way up to Chapter 12. Okay, now, let's just take this, whatever I have on the board, one thing at a time. We have three particles. That's the way we can write them, where we write the symbol, electron, proton, neutron. This has a weight of 0, a charge of -1, proton 1, positive 1, neutron 1, 0. Now, this is the symbol. That's what you put. And then in the superscript, you put the mass number, and that's the mass, 0, and then the atomic number. Now, the atomic number is actually a charge, but when normally we write it, such as here, we don't write positive 20, we just write 20. So when people see this configuration, they say, well, what's the negative or the positive? That's actually the way it's written, but we don't normally use that as a positive here. We simply say it's understood. It's still positive. It's the number of protons. This is the number of protons. This is the number of protons and neutrons, or the number of nucleons. Okay. Now, this is an atom. It's not an ion. An ion is a charged particle. For instance, chlorine. Chlorine is like this, right? Let's say it's negative charge. It's still going to have the same mass. We'll say the mass number is 35 and the atomic number is 17. But we're going to say that it is a ion. That's an anion of chlorine. Okay, just leave that for a minute. Okay, leave that for a minute. Okay. An atom is uncharged, ground state, the number of protons equal the number of electrons. For instance, if I have a particle where here's the symbol X, 50 is the atomic number, the mass number is 125, that's going to have 50 protons, 75 neutrons, those are the nucleons, and then 50 electrons. Remember, it's an atom, it's not an ion. When I say atom, protons equal electrons. When you say atom, you're automatically assuming ground state. Okay, so an atom is uncharged, ground state, number of protons equal number of electrons. Here, this is not ground state. This is an anion of chlorine. So it's going to have 17 protons. Well, all right, how many neutrons is it going to have? Well, it'll have 35 minus 17, which would be 18 neutrons. So I'll have 18 neutrons. And don't forget, you have an extra electron. It's a negative charge. So it's going to be 18 electrons. So you have 17 plus charges and 18 negative charges, and that's going to be a -1. And that's where you get that -1 charge. So an ion is charged. The number of protons don't equal the number of electrons, but for an atom they do. Now, let's look at isotope. An isotope is a variation of a particular element, such as hydrogen. These are three isotopes of hydrogen. These are three isotopes of hydrogen. An isotope is a variation of a particular element, such as hydrogen, based on the number of neutrons. The number of protons would be the same because it's a particular element. So these are all hydrogen. 1, 1, 1. It's hydrogen, atomic number. Here. Atomic number right here. Protons. Okay? However, protium has one proton and no neutrons, so it would have a mass number of 1. Deuterium, 2, and that would have 1 neutron. And tritium would have 2 neutrons. 2 neutrons and 1 proton, mass number of 3. So protium, very, very dominant isotope of hydrogen, has a mass number of 1. Deuterium, mass number of 2, and tritium, mass number of 3. They all have 1 proton. And that's really it. There's really not a lot there. Basic atomic structure, and good luck. This is a quick add-on. I completely ignored this right in the middle of the movie. And it's simply there to demonstrate that an isotope is a variation on a particular element based on the number of neutrons. This has an atomic number of 20. This has 20 neutrons, 21 neutrons, and 19 neutrons. This one does not belong because this is a different element. This is 21. The element is defined by the number of protons. So if you had these 4 choices, it would be this one that would not belong because these are the same element. An isotope is a variation on a particular element based on the number of neutrons. That is a different element. Thank you.